Hi everyone, Mrs. Basega here, and today we're looking at the three different types of collisions. By the end of this video, we should have reviewed velocity versus time graphs for the three different types of collisions, and you should be able to use those to tell the three types of collisions apart. So to start off, let's talk about inelastic or sticky collisions. These are collisions where your objects start apart, and because of the collision, they stick together. And as a result, after the collision, they move with the same final velocity. Good example would be a car crash or something like a football tackle. These two football players clearly have the same velocity afterwards because they're stuck together. Sticky. So, let's say I have one football player running to the left, that's blue, and one football player running to the right, that's red. The collision occurs, and red gets pushed backward and blue slows down. Its velocity was -8 before, and now is -2. It slows down because it transferred momentum to red. Now they move at the same speed at the end. Another way to picture an inelastic collision would be to draw it out with a before and after diagram. In this case, I only need to keep track of three distinct velocities because I can see A moving forward, B moving backward, and then A and B moving together, three velocities. On the other hand, elastic or bouncy collisions, these are two object collisions where our objects start apart and stay apart. This could be something like bumper cars, where these grown adults dressed as knights swinging swords are playing bumper cars. The cars never stick together, they bounce apart. Realistically, elastic collisions are special. A special elastic collision would be the perfectly elastic collisions that occur between atoms of a gas. In real life, perfectly elastic collisions not only conserve momentum, but also conserve kinetic energy. What would this look like then? On a velocity versus time graph, one object might slow down and the other object might speed up. You'll notice that blue was moving backward and then forward. So this must be the object on the right. It was moving left, then bounces back to the right. Red was moving to the right and is still moving to the right after, but slower than blue. Notice that when we do elastic collisions, they should cross each other in the middle because they change direction, or at least one changes direction. Let's take a look at this elastic collision in a diagram then. Notice that at least one of them changes direction. B was going to the left and is now going to the right. Red was going to the right and is now slowed down. Finally, superelastic collisions, also known as explosions. These are two objects that start together. They release some sort of potential energy, like think a spring, a chemical reaction, something like that. And as a result, they move apart from each other. So here's a very, very famous one where it releases chemical potential energy, and that would be a rocket booster. In this case, because the rocket booster jettisons the two fuel tanks on the side, it imparts additional momentum to the center. Similarly, let's say our people, they start with no kinetic energy and they release chemical potential energy in order to move backwards. All right, how do we draw this? Let's say for our people. Let's say our two people are rolling down the hallway with their rolly chairs, and the girl pushes the boy. As a result, he goes forward, but joke's on her, she'll go backward as a result of it. You'll be able to tell superelastic collisions apart because they start together and move apart from each other. What this would look like is two objects moving together to the right. A speeds up, B slows down. The rocket booster works the same way. When it jettisons the jetpacks behind it, represented by B, The center goes faster, represented by A. So that's all for your 3 types of collisions. Have a great day!